Yeah? Hello. Konnichiwa. Good morning. Thank you so much for having me. I'll be honest with you. My Japanese is very rusty, meaning like I know five words, five terms. But I will be trying my best to communicate with you all today. And I'm trying to acclimate myself with a little bit more of the culture here. One example, been trying to play around with a little bit of art. Maybe some of you have seen this. Artist who, by the name of Sawaratsuki, who created this art here, and I asked their permission. They were gracious enough to let me use it. We thought it was cute, very kawaii. So anyhow, let's get things kicked off. I'll do a brief introduction of myself. My name is Daniel Rosenwasser. I'm a product manager on the TypeScript team at Microsoft. I've been working on the team for just over 10 years. I recently hit over 10 years. And I started off as a developer on the team, as an engineer working for about 2 years before I switched into the product manager role there. And it's very interesting to give a talk here in Japan after 10 years because it really makes me reflect on sort of the humble beginnings of when I started on the TypeScript team itself. One interesting place that this kind of arose was I decided to kind of go back through memory lane and think about like where the community was back then. So GitHub has this thing called the Octoverse report that they come out with every year. In 2016, they came out with this report, and they had a ranking of the most popular languages on GitHub, according to pull request. And they also had a little percentage increase that you can see at the very left of what the growth rate is year over year. And TypeScript is nowhere to be seen on this graph, except at the very, very bottom right there, with an extremely high rate of growth, but with basically no base. And so the next year, you sort of start to see it moving a little bit inch by inch up on the rankings as well. And then in 2018, something really interesting happens where all of a sudden, TypeScript jumps into the top 10 in this like very vertical, very sudden, steep incline all of a sudden, which took us all by surprise because now we're starting to see this language, which is relatively young, join the ranks of these languages that I'd been using in school like years prior in those contexts. And it kind of happened again in 2020 as well, in the top 4, which really took us by surprise, right? Outpacing one of the other languages that Microsoft actually makes. And then something even more interesting happened this past year where in the top 3, we have JavaScript and then Python and then TypeScript. And this is astounding to me because Java, C#, C++, all these languages below, maybe with the exception of Go, I grew up with learning, using in different contexts, and they've been around for over 20, 25 years in some contexts. And here is TypeScript, something that I've been involved in for, a fraction of that time for each of those languages. And it really, of course, it has to do with the dominance of JavaScript, holding the first place year over year there. But if you look in other places where we see surveys like the State of JavaScript survey, they have a breakdown. They had a breakdown last year of where do people typically spend their time between JavaScript and TypeScript. And what we start to see is, for the most part, they tend to pick TypeScript as their daily driver of the thing that they spend the most time in, which is shocking, right? That doesn't mean that they're not using JavaScript, but it just means that maybe for this select group of developers that this survey captures, modern JavaScript development, you could call it, TypeScript is the choice, the language of choice. And that rate of growth continues because not only does TypeScript have a very large base of usage and pull requests and things like that, but the rate of growth is still in the top 3. So not only is it widely used, it's continuing to pick up steam, which is really not something that most languages you would imagine would continue getting. And the same goes is true if you look at other surveys, rankings, places like that. Stack Overflow's developer survey, TypeScript ended up in the top 5 or 6 or so. This is just surprising to me. Like, it just blows my mind, because if you look at NPM downloads, we hit over 10 million downloads a day at some point this past year. And then in 2023, we had over 2 trillion downloads of TypeScript on NPM. This really could not happen without the community that we have. It's all you. Everyone here has enabled this growth, this community, this outreach. So thank you very much for having me here. It's like very exciting to be here. But of course, I do want to spend some time today talking about what's new in TypeScript. Some of the stuff that we've introduced in TypeScript 5.4, and some of the stuff that's coming out in 5.5, and some ideas that we have going forward as well. So let us jump into an editor, and let me hopefully not break the AV system here. Yes, okay, cool, this is working. All right, we're gonna make this work. So the first thing I wanna talk about is a feature called Noinfer. It is maybe a little bit of a power user feature in some ways, but it comes up a lot if you're trying to create APIs and functions that are meant to be called a very specific way and you want to avoid making a mistake in them. So to get the stage set up, I have 2 classes, animal and I have dog. Dog extends animal and adds 1 method to it. So nothing too special here, right? You've probably seen this example many times. So the first function that we have is something called do something. It doesn't really matter what it is called. It just does some stuff. But the idea is that you have a default, and then you have some function that produces a backup value in some way, some default. And the idea is that when you call this thing, you want this default to be at least as specific as the original input value. Whatever you were expecting to pass in here, the default should be at least as detailed and specific and narrow. The problem is that when we call this function, we say, like, well, here's a dog, and here's something that produces an animal. It actually is fine with that, right? We would prefer that it errored and say, no, you need to provide a dog in both branches, in both parameters. But what's happening is when it does inference, when we do inference, TypeScript sees that there's a T. And it says, what could the type of T be? It walks the types of each of these expressions and says, well, I have a dog here and I have an animal here. And now it has to make a choice. What is the type of T going to be? Well, it tries to do something called subtype reduction and then says, well, a dog is a subtype of an animal. So probably what we mean is for T to be an animal, and then that's what we get inferred here. This is, if we didn't want this to happen, one little hack, one little way that you could approach this is you could introduce a new type parameter. You could say other. You could say that it needs to be at least as specific as T. And then we would say that this thing is going to take an other type. So what will happen is we will come up with an inference candidate for T. We will come up with an inference candidate for other, but when we figure out the type of T, we'll say, well, that has to be a dog. And other needs to be at least a dog or more specific, and so it'll fail when we actually try to perform the assignment of animal. So that's one way that you could do it, but it's not, well, I'll get to some of the shortcomings in a minute, right? I'll show you 2 more examples as well. Maybe you have an assertion function that you use in testing, assert equal. It takes 2 T's, and you want to be able to say that the thing that you pass in for the actual is at least as specific as the expected, right? So if I have an X and a Y property, the other object should have at least an X and a Y property as well. But here, there is no error. So we could apply the same sort of trick. We could say that there's an other, extends T, and then thread that through right here. And we get the error as we expect, right? So now it says Y is missing in this type. And the same thing can be witnessed in a similar sort of example. Maybe we have something called create state, and it takes a list of 3 different, or any number of string values, right? And then you pass in the initial state that you want. So it has to be one of the values in the list here. The problem, and you'll see this as I type it out, if I misspell this, it says, yeah, sure, that's a state, whatever, I don't care. Like, it just comes up with a new value that, or a new type that it could be. It says this S is as good as that S. And so it's all fair game and it'll work, which is not desirable, right? If I write orange here, that's clearly not in the list. If I misspelled blue, that shouldn't be allowed. So you could do the same thing here. You could say there's an other, if we can spell correctly today. Other extends S. And great, like I just showed you the thing that I've been talking about. But there's a couple of problems with this, right? If you introduce a new type parameter, one is that you have to start thinking about this type parameter everywhere in your API, especially if you start to think that if you want to add a new type parameter, you now have to think about the ordering there. You have to think about defaults in some cases. And also, it's generally not great practice. It's like here, it's probably fine. But generally, we try to come up with like mental frameworks for when you shouldn't write a specific type of code. And in this case, we tend to tell people that if a type parameter only exists in the input positions of a function signature, and it's never used in any other parameter or any other output, there's probably something that you're doing wrong. So that's kind of like just a mental framework thing. It's not a bad thing per se, but we like to try to avoid it when possible. So the thing that we introduced, and I'll undo until we get to like the top of the file, is we introduced this new thing called Noinfer. And it does kind of what you would think it would do. It basically says that as soon as you are trying to reach this, like as soon as you are taking each type and trying to link them together and see whether or not they can match up, as soon as you hit this Noinfer, don't go any deeper. Basically, if you wrap a type in Noinfer, it means that it is not considered a source of truth for inference at all. So this T is really just used for checking for compatibility. It's not meant to be used as a reference. So if I remove this, it incorrectly passes. But now if I say Noinfer, I can actually reject this outright, and I can say, no, this thing needs to be a dog. It needs a wolf method, right? Or same thing here. I could say Noinfer on T. And now we get the same error that we're missing the Y property. And the same thing around here. I can say Noinfer of S. And, well, I have to make the mistake. Right? And so this is going to say it has to be one of these three string literals. So Noinfer, you can use it in some flexible ways. You can put it around a specific type parameter. You can put it around an entire type structure. So you can say, like, nothing should be inferred from this expression, which is helpful if you have like multiple type parameters, or if you have to use the same type parameter multiple times in an entire type that you write out. So it's a bit of a power user feature, but if you need to create APIs that are called in a very specific way, it can be very helpful for avoiding mistakes and things like that. So that one landed in TypeScript 5.4. Something I'll show out from TypeScript 5.5 is actually not related to, it's not TypeScript, it's actually JavaScript. So many of you are probably familiar with the TS checking mode for JavaScript files. By show of hands, how many people use TS check or check.js? There might be a delay in the translation. Or maybe no one uses it. But basically, the idea is that a lot of the time, you just want to write in plain JavaScript because maybe you have no build step. You want to be able to just run your file directly in Node.js or in the browser or whatever. Often this is build scripts. Often it is like one-off things that you put within a web page. And the way that you do this is you use JSDoc to power all of that. Because type annotations aren't understood by browsers or certain runtimes. And so what you can do is you could just add comments that TypeScript specifically understands how to check on. And so you can say something like, at type number, and then if you say like let x equals hello, we'll get an error saying a string is not assignable to a number. And so this is all doable in JavaScript. It's very flexible, but there are shortcomings because JSDoc is something that we just kind of adapted from a format that was built for documentation generators. It's not really meant for easy authoring, for type checking and things like that. It predates modules. And so if I wanted to use the animal class that I declared over here, the way that I have to do that in JSDoc is I have to write something like this. Right? I could just write this. And so now if I hover over it, it says, oh, this is an animal. I can jump to the definition. All of this works in my editor. It's really convenient. But this is pretty gross, like writing this out. And so if you want a local import of a type, you can write something like this. So you create a type def, which is a type alias. It's kind of like writing type animal equals this thing. And it works, but it kind of sucks. Because if you want multiple of these, you have to start writing, oh, okay, dog is this thing. And then you have to do the cat. And then like it gets very repetitive. It gets very annoying. So one of the things that we added in TypeScript 5.5 is now there's just a new thing that you can use to import types and entities. You could just say @import, and you could say import star, or let's just say animal for now, from .. and you get all the autocompletion and all that stuff that you're expecting. And it uses the same syntax as your regular imports as well. So I could say from this thing, and then I can use animal here, get autocompletion. I can jump to the definition. It just works. If I decided, actually, no, this should be a dog, beautifully, auto import just works in that comment as well. So this is like a nice quality of life improvement, right? If you've been using JSDoc and JavaScript checking for a while, this might feel like a breath of fresh air. This is a huge relief. If not, I hope you give it a try when you've been wishing for TypeScript in a file that you can't compile in some way. Like this is super convenient for those contexts too. So that's landing in TypeScript 5.5, which is out in beta mode, but you can use in nightly versions today. And you know, this format, it kind of gives a good segue, a good transition into what I want to talk about next, which is regular expressions. So I kind of have this, like, I'm very skeptical of regular expressions. My intuition is we all write regular expressions. None of us are writing them right. We're all making mistakes, and they all have errors in them. And I mean, okay, this is an exaggeration. Like there are simple regular expressions. We use them for one-offs, but like if you use them in too advanced of a mode, if you're too clever, your cleverness will lead to a production outage in some way. So what we would like to do is try to help curb some of those errors, right? The typical thing that we would recommend is, of course, write some good tests for your regular expressions. But we need to find ways of avoiding the issues before you actually need to run them in the first place. And so until recently, TypeScript would not really analyze any of your regular expressions. In the latest version of TypeScript, we actually now are doing syntactic, analyzation. We're syntactically analyzing your regular expressions, making sure that they are actually valid. And so each of these has an error in them, and we'll kind of go one by one to understand what they are, right? So I'll remove the error suppression comment here. And the first thing that we see is an error. And it says unexpected closing parentheses. Did you mean to escape it with a backslash? It is what I meant to do. That's why the error message exists there. What you might have thought is because I have this escaped back, opening parenthesis, I don't need the same one for the closing parenthesis. And this thing is telling you, reconsider that. You might have an error here. And so we have to add a backslash. we can also, this one is actually based on a real example. On the TypeScript repository, we actually have a bot that we try to trigger. And there are certain phrases that we use to trigger certain commands for this like automated bot to do certain tasks. So we will say, TypeScript bot, do this faster, do this. And like there are certain words that people might actually ask. So like they might say please in some cases, and we want to ignore the please and the immediately and the whatever. But so it's a flexible comment. We use a regular expression for that. And if I remove this suppression, it's a little hard to see, but it says unexpected closing paren. Again, same deal, but the actual thing that happened was I just had too many of these because like I had a bunch of nesting and I kind of misauthored it. So I just need to remove one of these. A similar like realistic example is we were just talking about the import syntax right here. In that import syntax, we might want to use a regular expression to do a code mod transformation. I mean, you probably should use a real code mod transformation, but like if you're just running through a file, a regular expression is not a bad idea. And so if we wrote this back reference here, we were hoping that it would reference this thing, which is like the name of the import that we're trying to bring in, right? And the error here is this back reference doesn't exist. There are only 2 back references here. So the third one clearly must be a bug. Or if you're saying number 3, it's a bug. So we probably meant to say 2 here. And then maybe, you know, numeric back references are not super maintainable. And so you might want to use a newer regular expression feature like named capture groups. So you can actually name the capture group in these parentheses right here. And so this one is going to be called import path if you need to reference it previously. And this one is going to be called import entity. If we remove this thing, we get an error saying that imported entity doesn't exist in the regular expression at all. And so now, if you make this slight typo, you can catch it before you ever actually run this thing. You can actually say like, yes, this thing does exist in the regular expression. That was unintentional. Thank you, TypeScript. You're making my life a lot easier. And so this sort of thing, we're hoping to improve on it a little bit as well, maybe in terms of the error messages, maybe in terms of like what you can do in the regular expressions. This actually came from a community pull request from a user by the name of Grapheme Cluster. And we're really grateful for their work on that. We had to collaborate and iterate a lot on their pull request. On the same note, this JSDoc thing that we worked on as well, that came from a community contributor named Alex Harasyuk, who's done a bunch of contributions to TypeScript as well. And I think that brings me to my last demo in the editor at least, which is this function called getUserPages. So the first thing I need to do here is I need to go back in time because I want to show you the before and the after. So I'm going to jump back to TypeScript 5.3 about 6 months ago. And the idea of getUserPages is it takes an array of user IDs, right? Something that might look like this. And it creates a bunch of URL strings that you can use to actually like access the home page of a user, right? And we are taking the base URL here, which is going to look something like this, because we need to parameterize it because maybe we have a crazy CEO who wants to rename like a website from like twitter.com to x.com or something like that. And so we need to be proactive and defend against our overlords and make our code a little bit defensive. So what we will do here is the first step is we'll take the base URL and we'll create a new URL object out of it and reassign it. And that does 2 things for us, right? If we have a string, well, we have a URL object that we can act on. But if we have an existing URL object, we are creating a local mutable clone of that thing, so I can do whatever I want with it, in a sense. So the cool thing here is, maybe you're all used to this, but if I hover over base URL after the assignment, it actually has a different type. This process is called narrowing. As TypeScript does control flow analysis to type check, it will say, look for all of the assignments and the checks that we've performed earlier in the code to determine what the type is in this position. So if I wanted to grab search params and assign it to the first user ID, or I wanted to say .set user ID to user IDs of 0, then that would just work because now I have search params on the URL object and I could just make this work. However, let's just put this back here. However, if I now decided to actually implement the function, I say .map, I can type today, user ID, and now I try to say something like base URL dot, I've lost all of the members here all of a sudden, which is kind of confusing, right? Well, we can just hover over this and get a sense of what's going wrong. Now I'm left with stringer URL again, which is annoying. Because what's happening is TypeScript says, this is contained in another function. It's not in the current scope. So I have to take the most conservative view of all of the narrowings and control flow analysis that have ever happened. Basically, I have to say it just goes back to the declared type, which is this union type here. And the reason for that is it kind of makes sense because if we had written a helper function like this, a function declaration, I wrote base URL, this thing can be called anywhere because function declarations are hoisted. So it's actually not an error for me to call this function up before I've ever reinitialized or reassigned the variable at all. So this hoisting behavior basically acts like you had just taken all of the code, all of the function declarations like this and moved them to the very top of the file before anything else has happened. So it makes sense for those. But function expressions, like arrow functions and lambdas or whatever you want to call them, have a very different system. They are not referenceable until you actually execute the code that you hit, where it's actually written out, which means that all of the prior stuff that you've done has actually executed. So what happens here is, what we did here is in TypeScript 5.4, we made a change to control flow analysis. So let's jump back in our time machine and go forward in time to today. If I get rid of this code, if I now dot, I actually do have search params available to me again. Because now, if we hover over it, we have a URL object. And what's happening is we're saying, OK, let's do a little bit of extra work. If we can detect that the last assignment to this variable occurs before the use of that within that function, then it's actually fair to preserve all of the refinements or narrowings or whatever you want to call it around that type. So now we actually can depend on this assignment of changing the type here. And so now we can do the correct thing. We could say .set of user ID, and then we can return this whole thing. Oh, and we actually have to, return the string of the URL. So this is good because if I had to go back to TypeScript 5.3, what would happen is I would need a cast. And the problem with casts is, or type assertions, is you're asserting something to the type system. You're trying to convince the type system that you know something better than it does. And when that goes wrong, where that goes wrong is when you actually decide, when you've made a change somewhere else, and your assertion has become a lie to the type system. It's no longer true, and the type system can't convince itself otherwise that you have not kept up with that information. So that's one really nice improvement that we made in TypeScript 5.4. Something else that came up recently is something called, let's go through a motivating example here, right? So let's say we've decided we want a different format for our URLs. We now want something like usernames as part of the path name here, rather than using a query string, because maybe you think that the path name is a little bit cleaner than the query string. So like this, this no-go. And then this one, yes, we want that. So conveniently, we still want this function to exist because we have other places in the code. But we have a function that will take a user ID, will take this thing, and will produce the username if it can. If it cannot, it will produce the value undefined. And so this is an asynchronous operation. We'll just make that work. So what we can do here is we can now say, let's get the usernames. So we would say user IDs dot map on, what do we call this? Get username from ID. What we end up with is an array of promises of string or undefined. So let's flip the promise in the array. Let's take promise.all of this thing. Okay, great. Now we have a promise of an array. Now let's await the thing. All right, now we can actually do something with the data. We have an array here. So it's an array of strings or undefined. Some of those have not succeeded, and we just want to throw them away. So what we'll do here is we will say dot filter user name, and we'll say, okay, all the ones that are undefined, throw them away. Keep only the ones that are not undefined. So now we should have an array of just strings. Let's kind of continue and just say return usernames.map. And we have to say base URL dot path name. And remember, we're in TypeScript 5.3, so we have to keep that cast around now, the type assertion. Okay, fine. And then we want to assign the username to that. And now we have an error. What's happening is it's saying that string or undefined is not assignable to string because username might be undefined. But I just got rid of all the undefineds. So what's happening here? Well, the problem is that even though this function is doing all this narrowing within it, inside that lambda, we are just throwing it away effectively. Like TypeScript doesn't do anything with that information, and all of it comes back as just a Boolean, right? If we just hover over this arrow function, we see that it doesn't do anything specific. What we could do is we could say that this thing is a type guard or a user-defined type predicate. So we could say username is string. And what this says is when you call this function, if it returns true, then you can narrow whatever you passed in to a string. And filter has an overload that says, if you give me a type predicate, something with this signature, value is S, it'll infer S to some subtype of whatever the underlying array has and return an array of that, right? So now when we say filter with this thing that says all the truthy elements are strings, we actually do end up with a string array, and we can do this, which is cool. It's something you could do in many versions of TypeScript. But it's not great that we have to add this manually, right? We really like to have people just kind of think about writing the JavaScript code that they want without having to think about the fact that they're in TypeScript. So one of the things that we got a phenomenal pull request for in TypeScript 5.5 from a developer named Dan Vanderkam is we can now actually just get rid of this. And the code still works. Actually, since we're jumping forward in time, we can get rid of this type assertion too. All of this code just works now. There's no cast, there's no explicit type predicates, anything like that. Because what's happening is if I hover over this function again, notice that it actually is saying username is string. What we're doing now, what the most recent change that we've done is, if we see a Boolean returning function, we say, well, can we learn something from that Boolean returning function? Does it have some interesting information that we can propagate to the outside? And so we will infer type predicates, right? And we'll say, from all the places where this function joins, have we learned some sort of consistent set of information about a specific parameter? And if we have, now this thing can be a type predicate. When that happens, filter picks the right overload, That write overload propagates outward, so you have an array of strings, and now this all just works, right? And so now we can just say return a stringified version of the base URL object that we, sorry, the base URL object that we've been constructing, and it all just kind of works. The thing that we always strive to do with all of this narrowing and type analysis and all this stuff is we want you to think about writing your code as just what the actual JavaScript is going to do. We don't want you to think about, oh, I need to cast that. Oh, I can do this if I do this in a certain way with a type assertion and whatever. It makes you bend over backwards for the type system. Whereas now we're kind of just modeling what the JavaScript itself will do and not getting in your way. In fact, the only TypeScript that is in this file is this annotation and that annotation. If you tell us what your parameters are going to be, we figured out the rest of it for you. So I think that's like a really beautiful thing, like a powerful thing in the language. We always strive to actually ensure that we have that available to you. So I also feel the need to call out that many of these features, like the major ones that are landing in TypeScript 5.5, were contributed to by the community as well, which I guess brings me to the transition of back to the presentation itself. So we have new TypeScript 5.5 features I just showed you, and I want to talk a little bit about performance and scaling, right? Because a big part of what our team has been working on has been just like smoothing out the experience, making sure that you don't have to restart TS servers often, and just making things faster. Like we've actually made TypeScript 5.5 faster in the same way that TypeScript 5.0 is faster, just by doing some basic architectural changes, but specifically for your language service experience and for if you're using the API. And so if you're using like TypeScript plugins in Webpack to type check, or if you're using just like the editor, TypeScript 5.5 should feel much snappier, which is really nice. But there's another scaling effort that we've been collaborating with teams at Bloomberg and at Google on, which is called isolated declarations, which I'd like to talk a little bit about. So I want to talk a little bit about project references. TypeScript project references are a way of breaking your code base into several different projects, like units of compilation that can be done like in a somewhat independent way of each other, right? You basically have a separate output directory. You don't have to do this. You can basically do some incremental compilation based on doing the most minimal type check and build based on a change in another project. And that's very convenient. But there are some issues with project references. So let's actually try to let's do a build from the top down and to see what I mean about this. So let's say we wanted to build utils. So we now start to type check utils. We have to wait. When that works, it's going to produce a declaration file. So that declaration file is a digest, right? You've all probably seen declaration files. They contain just types and signatures of functions and variable declarations. But they don't actually contain JavaScript code, because the entire idea is whenever you need to compile against a declaration file, those are just implementation details, and they're just extra code that need to be parsed, and they become more expensive to load up. So when we compile components, it only needs to care about the signatures that are available to it from the public API, which are in the declaration files, right? So we have to do the same thing for components now, right? We have to wait. When type checks, generates declaration files. And then when we need to compile the two dependencies there, we have to compile it, it works, compile it, it works. We don't need to produce declaration files for these two projects at the very bottom, because no one else depends on them technically. So who cares what the public API is? It's really just about what the actual thing does. So it works, right? It's useful for incremental compilation. But one of the issues is that if you are at a certain scale, and specifically the scale that we have partner teams at Bloomberg, Google, many other companies that have like hundreds or thousands of projects in some cases, basically you may say, well, we have all this hardware with all these cores, and they're just sitting idly waiting for the bottleneck to be compiled. So for example, if you have 16 cores, let's say, and you have these 4 projects, at the very most, if you try a way to parallelize this entire compilation, you can use 2 of those cores once utils and components have each independently been compiled. So that bottleneck is pretty painful. And that's common. You will often have like the serial dependency issue. But you can kind of think about this a little bit differently, right? If you reframe the problem, or if you reframe things as dependencies on declaration files rather than on projects, then you can now start to think about things a little bit differently. You can say, what if there's a way to get the declaration files without having to do the build? And so that might be somewhere you can be a little bit creative. What if this thing didn't require type checking? So like we'll come back to that in a bit, but if you had that model, what you could do is you could emit all of these declaration files first, up front, right? And that could be fast. That could be done in parallel. It doesn't really matter. But as long as it's speedy, then all of your dependencies are immediately satisfied between your project references, which means that you can check them in any order that you want. And actually, because they're all independent of each other, it means that you could just check everything at the same time if you wanted as well. So you could just check them, compile, and you're good. And that's great. But the problem is that if you actually need to generate the declaration files today, let's say you wanted to create a declaration file for that add.ts file, well, you can create the signature. You can derive the signature from the code that was actually written. But then you still need the type. So how do you get the type? Well, TypeScript basically says, let's look at the body. The body has this variable. That variable goes to another file. Let's load up that file, grab that variable, and then go to the initializer. This looks trivial to us. Like you could imagine that bundler could be a little smart about this. But the truth is that that string could be arbitrary. It could be actually like a function call. It might need inference. It might need a whole bunch of these things. You need a type checker is the end of the day for this. But what if you just added the annotation itself? Well, then it becomes trivial to just like preserve that in the declaration file. And so that's one of the solutions that we're looking at is this mode where you actually just annotate your public surface API, right? So we've added this flag called isolated declarations. And it's basically meant to give you an indication that your code can be compiled with an external tool that is not a type checker, that needs no type information. It just needs syntax. So when you, and it only needs the public API, so everything that's exported. So in this example up here, 1 and 2, those variables, they don't need any annotation because no one cares about them in the declaration file. But that function is exported and it needs a return type. Once you give it, isolated declarations will stop complaining about that. So there are some trade-offs here because that can allow these interesting build systems where you can parallelize, you can build in like, this very interesting way. And this isolated declarations mode is something that we've been collaborating with these other partner teams that are actually deploying them with a lot of success, where they're actually getting much faster builds at this point. And I have to give credit to Titsya and Dragomir, who has been collaborating with us at Google on this feature and like actually landed in chapter 5.5. There are some trade-offs, which is that in some cases, isolated declarations can infer the types of simple expressions, but you might be surprised about where it cannot. For example, in the previous example, if I just have an object literal, we do a little bit of extra work. But if I have this thing in object.freeze, that might be an error because who knows what object.freeze will do. And so there is a little bit of this tension. So going forward, like this is what's new in TypeScript, but I'll give you a little bit of a teaser. We're also experimenting with some other stuff, which is we started thinking about things a little bit differently, where if you're in your editor and you hover over this function right here, like you put your cursor over it, you get quick info. To calculate that quick info, that's basically the same thing as what you'll see in a declaration file. To get that, we jump into the body, we start looking at the variables, we resolve the variables, we check this stuff, and we can get it, we can calculate that. But notice that like we don't actually need to look at the entire program to do that. this is a pretty lazy process. The entire language service that we've built and constructed is lazy by default. So one place we're trying to experiment with is, can we just speed up declaration file emit by being lazier here? So maybe there's a middle ground. If you're looking for this highly parallelizable build system, isolated declarations might be for you. If you're looking to use ESBuild or SWC or some other build tool to bundle your declaration files or build your declaration files, isolated declarations will be for you. But we're also trying to find ways that we can also just lower the barrier to entry and make things faster too. So time's up already, and so I'm just going to wrap up. So I appreciate the patience here. First off, I'm going to be here at the conference. I would love to chat with all of you. We'll make the language barrier work somehow. So I'm excited to meet with you and talk to you all. But please keep in touch, right? File issues on GitHub if you ever run into any. You can always become a contributor if you're interested in that. There are often some nice, easy bugs to get started out with. We have a Discord community if you'd like to chat with other developers who are also as excited about TypeScript as you are. And then we have social media platforms that we're on as well. I do want to wrap up on one last note, which is I mentioned that I've been on TypeScript for about 10 years now. And I still remember in the early days when it was still a small community and I would just be chatting with random developers around the world, helping them try to fix their problems, try to figure out how to set up TypeScript. And it was something where I just thought it was so cool that I could meet other people who loved this language, who loved TypeScript as much as I did. Everywhere, including in Japan too. And the idea that I would be here speaking to you all in Japan 10 years later is not something that ever remotely crossed my mind. Thank you all so very much for accommodating me, for welcoming me. And it has been a pleasure. Arigatou gozaimasu.